Previously, we talked about central angles. Today, we're going to be taking a look at something called inscribed angles. So let's compare and contrast here. Central angles, and we got a little definition down here. Central angles is where the arc on the outside is equal to the measure of the angle. So central angles are centered at that center here, and they open up and create an arc. All right. So if this was, say, 40 degrees, the outside from here to here, that part of the circle, the arc, would also be 40 degrees. They're the same size. Now, inscribed angles don't touch at the center. Now, sometimes they may pass through it, but they don't start there. So let's say we have an angle that looks like this. Okay, it still opens up and creates an arc. You still see that pizza shape from here to here. You got the crust. This time, the inscribed angle, the arc is twice as big as the angle. So let's use the same number here. If this was 40 degrees, it opens up and you see it covers more of the circle this time than on the central angle. So this one's twice as big. So if it's 40 inside, it's 80 outside. So if it's at the center, all right, if it's at the center, it's the same size. If it starts somewhere else on the outside of the circle, the arc is twice as big. All right, so we're going to be using that today. So let's take a look at some examples. All right, we've got a nice large circle here. I'm going to draw the center of the circle just for reference. And they're going to give us something that looks like this, where this is C, this is E, and this is D. And they're going to give us some numbers. Over here is 97 degrees, and over here 101 degrees. All right, so maybe not completely drawn to scale, but we get the general idea. And now the question that they're going to ask us is, what is the measure of angle CED? All right, so the measure of angle CED. So it says angle, so that's the inside part. So from C to E to D, I want to know how big that angle is. I need to find that piece in there. All right, so that's my question mark. I don't know how big that is. Now let's kind of trace it backwards. See what it's connected to. CED opens up and creates this arc out here from C to D. Now let's say I knew what this number was. I know that's related to this one because it's twice as big, or I could cut it in half and then find out what the question mark is. But I don't know what this is yet. Okay? So once I do find that, I can cut it in half and find out what the angle is. But let's look all the way around this circle. Let's see what we do have. I have a 97, and that represents from C to E. That's 97. I also have a 101, and that represents from E to D. And you see now I've colored all of the outside circle. The 97 is that piece, the 101 is this piece, and then I don't know what this blue piece is down here. But it's made up of 3 pieces. We know that a whole circle adds up to 360 degrees. And if I know 1, 2 pieces of it, the way I could find the third is add those 2 pieces up and subtract them from 360. So right now I have a 101 and a 97. Let's add that up, and we get 8, 9, 198 degrees. Subtract that from 360, and that'll tell us what that blue piece is over there. All right, so we got to borrow 5, 1, 2, we got to borrow again, 4, 142? No, 162. Math is a little off. All right, 162. So I can erase this question mark out here. This is 162 degrees. Now that's not what I want. I still want this inside angle. But I know the outside is twice as big as the inside, so I can divide that by 2. Divide it by 2, and I should get an answer. So angle CED, cutting that in half, 81 degrees. So we found out that that inside angle there is 81 degrees. So we're kind of problem solving, got to puzzle all this together, trying to figure out what we have, what we're missing, and how we're going to find that. So let's see this again. All right, so got a circle with a center. This time, they're going to give us something that looks like this. All right, I'll just put a dot to kind of cover that up. All right, we got X, we've got W, and we've got V. And let's see what numbers they actually give us. Over here, this is 43 degrees. This here is a 50 degrees. And this time they want us to find the measure of WV, but there's that symbol over it. That means it's an arc. They also want us to find the measure of arc XV. So let's find it piece by piece. So the first thing they want us to find is arc WV. So arc, that's the outside, that's the pizza crust. So let's mark it from W to V, from there to there. Okay? Now that is made up of two lines, and let's trace that back. Let's see if we can make a pizza slice out of it. This goes to X, and this goes to X. And look at that, we have the inside. And I know, since that's an inscribed angle, this 43 is related to this outside piece here. And we know it's double, twice as big. So 43 times 2 means this outside piece should be an 86 degrees. I just have to double it to get the outside. So the measure from here to here, 86 degrees. All right, let's find something else. The measure of arc XV. So XV is this piece over here. I can trace it back in. This goes to W, this goes to W. So if I know what this is in here, I can double it and find out what this is out here, which I'm trying to find. Now I don't have the inside yet. So if I don't have the inside, let's look at other numbers that we haven't used. I have a 43, I have a 50, and if I look inside that circle, that's a whole triangle right there. From X to W to V and then back to X, that's a triangle. And triangles add up to 180. So if I have these two, I can add them up and then find out what this is here by subtracting it from 180. So the 43 and the 50 add up to a 93 degrees. Subtract that from 180. Let's see, gotta borrow that. Get a 7, gotta borrow again, 17, 87 degrees. So I know that this angle in here, and I'm gonna erase that question mark, this is 87 degrees. Not my answer yet because I still want to find out what the arc outside is, but I know if the inside's 87, I can double that to get what's outside. So 87 times 2, let's see, that's a 4, 1, 16, 17, 174 degrees. So the outside here is 174 degrees, and that's what we were looking for. All right, so we found both of those pieces that they asked for. So again, puzzle solving. We gotta use some of the rules that we learned previously. Like a whole circle adds up to 360, a triangle adds up to 180. More circles. And there's the center. All right. So this time we've got kind of like a kite shape in here. All right, and I'll label the outside. So we've got R, Q, P, and K. So that's where they hit the circles. So still, these are all inscribed angles because nothing touches the center there. And they give us that this one right here is 110 degrees. This piece out here is 50 degrees. And what they want us to find this time is the measure of arc PQ. Arc PQ. So a good idea is to start with what I'm trying to find. So P to Q on the arc, that's the crust. So, oops, not that one. P to Q is this one here. All right, so I need to find that. So if I trace that back, Q goes to R, but P goes off to K, so that doesn't close in at one angle, so that doesn't really help. So let's use other stuff. How about this 50? That 50 represents from K to P. All right, but that doesn't trace back to any angle either. All right, let's see what else. I've got the 110. The 110 is this angle, so let's trace the arms. 110 goes to here, 110 goes to here, so that means there is an arc on the outside that's connected to this. So I'm just looking at that yellow piece. So if the inside is 110, the outside from Q to K should be twice as big. And in fact, that's going to be all that there. Twice that is 220, not 222, 220 degrees. All right, so let's see how that helps us. At this point, I kind of look. I've used up every number I had. All right, 50's there, 110 became the 220. So let's see, I'm still trying to find out what this is from Q to P. So let's see, I've colored actually all the outside of the circle. Pink is 50, yellow's 220, green is what I need to find. So again, I know the whole circle's 360, so I can add 50 and 220. That should give me a 270. Subtract that from 360, the whole circle, and that'll tell me how much is left, the green piece. So 360 minus 270 actually gives me 90 degrees. So there we go, PQ, 90 degrees. The missing piece, 90 degrees. All right, one more example of this. Okay, last example. So there's the center. They'll give us this. Again, no central angles here, just inscribed. S, Q, R. They tell us from S to R is 75 degrees. And then this is 80 degrees. And they want us to find the measure of arc SQ. All right, so what I'm trying to find is SQ, so let's mark that off. S to Q, that piece there. You see that doesn't close into one nice angle on the other side, so we don't know that yet. So we've hit dead end. Let's see what we do have. I know from S to R is 75. That doesn't lead to an angle anywhere either. Then I have the 80. The 80 is an angle. If I open it up, that creates the arc from R to Q. If the inside's 80, the outside would double to become 160. And this looks similar to last time. I've got three colors on the outside of the circle. The yellow that I'm trying to find, the 75 is the blue piece, and 160 is the pink piece. I know the whole circle's 360, so we're going to add what we have. So that's a 5, that's a 3, carry the 1, 235. And then subtract that from 360, and that'll tell me how much that yellow piece is, how much is left. So borrow the 5, 1, 5, 2, 125 degrees. So the yellow piece, 125 degrees. So the big thing to remember from this lesson and the lesson before, central angles are the same size, 40 and 40. Inscribed angles that go all the way across, 40 and 80, are twice as big. All right.